In 1.3, what we're going to be looking at is modeling with linear equations. In writing a mathematical model, what we're going to do is we're going to be translating key words. And so what we're going to be doing is we're going to be looking at algebraic expressions, and we're going to be looking at words. And so this nice little chart called Translating Keywords and Phrases can be found in your textbook, or it can be found also in the modules in Canvas. And so we're going to work some examples and show how we can take words and turn them into equations. So kind of part one, make sure you're taking notes, write this down, those will help you later. So kind of part one, translating. And so what you want to do is we want to be able to take x plus 4, we want to be able to take x plus 4 and not move it around. We want to be able to take x plus 4, we want to turn it into words. And so you can see that I have the phrase, the sum of a number and 4. And so sum comes from the use of addition. You can go back to translating keywords and phrases, and that's where I got the word sum from. This is not the only way to write this, just one example of it. Of a number, and that's just another way of saying x, or a variable, and 4. So this is just one way of how we could write this. The second way, you'll notice I have 2x plus 4. And we wrote this as the product of, again, so product in this case is going to be multiplication. Whenever you have a number and a letter just smack dab together like that, that's multiplication. The product of a number and 2, so that means I'm going to take a number and 2 and multiply those together. That's where the 2x is represented. Increased by, so there's another name for addition. This time I didn't use sum, I used increased by 4. Now this next example, it's going to lead us in the next example, and one that you'll see in your online homework. It says the product of 2 consecutive natural numbers. Well, consecutive means that they come one right after the other. Natural. If you think about how a kid learns to count, if you're teaching a child how to count, you don't teach them how to count with 1/2 or 7/8 or negatives or even 0. You teach them like 1, 2, 3, da 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 da. And then when they get really good, they can count to 100, and they want to show you how they can count to 100. So when we're talking about the product of, product is going to be in multiplication. 2 consecutive means they're going to come in order, like 1, 2, 7, 8, 101, 102, stuff like that. Natural numbers, so we're talking about 1, 2, 3 all the way up till infinity, but we're not talking about fractions, decimals, 0, negatives. So if I'm talking about the product of 2 consecutive natural numbers, so I'm talking about 2 numbers, I don't know what they are, I'm going to multiply them together, and because they're consecutive natural numbers, you'll notice that to get from 1 to 2, I would say plus 1. To get from 2 to 3, I would say plus 1. So you can see that all of the natural numbers are 1 unit apart. So if I go back into my example and I'm talking about the product of 2 consecutive, they come in order, natural numbers, they're 1 unit apart, I could call my first one x, and because there's a plus 1 between 1 and 2, they're 1 unit apart, the next consecutive one would be x plus 1. So you tell me what the first number is, and I can tell you what the second number is. So another way of writing this would be x parentheses x plus 1, and a lot of times you want you to go ahead and multiply that out so you could distribute, and that would give you x squared plus x. And so in this case, I was just writing an expression. I didn't actually solve it out, but I would say the product, that's why I multiplied, 2 consecutive natural numbers, and there's conversation to go along with that. So we can do another example, and this one may sound familiar. This is one of those common formulas if you're looking in the book, which you can access through WebAssign. It was optional just because I knew you already had the e-text. The area of a triangle with base 16 inches and height 8 inches. Well, the area of a triangle is a common formula. I would assume that you would know this. If you don't, just kind of to revisit that, it would be A equals either 1/2 base times height, or that is also the same of base times height divided by 2. So whichever one you're most familiar with. But again, you can check that out in the book, or that is something that we do recall from memory. So the area of a triangle with base 16 inches, so in this case, This right here would be your B that we have in our formula, and height, H inches. And so in this case, we're just going to be using H. So in this one, not only did we have to recall a formula or write an equation just from that fact of it saying the area of a triangle, but then I'm going to fill in some extra information. So I'm going to plug in B to be 16, so I would say A equals, I'm going to use the 1/2 one, 16, and then H inches. I'm just going to leave H in there. So in this one, you had to recall the formula, write it out, plug in whatever they gave you, and then simplify it up. So this would give me A to be 1/2 times 16. That would give me 8H. And so in this case, that's all they're wanting for. There's not a matter of solving it out. There's not a matter of actually finding the area of this specific triangle. So this next example is going to refer back to examples. You see in this one, we see 3 consecutive, I keep moving it, 3 consecutive natural numbers. So again, we're talking about things that come in order, and we're talking about 1, 2, 3, and on up into all your positives. I'm talking about sum, so I'm talking about addition. I'm looking at 3 of them, so I'm going to draw me 3 blanks. I'm going to add them up because I'm summing them up. If the first one is x, we talked about this in a previous slide, that it would be +1 apart, all of these numbers. And so I'm going to come in here, I'm going to call the next one x plus 1. And then the third one, I'm going to call it x plus 2. And the reason I'm going to call it x plus 2 is you'll notice for me to get from 1 to 3, it actually took 2 units. And so I don't want to make up a new letter and call it y or anything. I want to revert back all the way to my x so I have the same letter throughout. And then next is an equal sign, is 84. So instead of looking at is, I want to look at this red equal sign. So I'm going to say equal to 804. Now I know that you could take a logical route in working this, but this would be, excuse me, there's my fake cough, it comes up sometimes. This might be a good test question, excuse me, test question, because what I would be looking for is can you create this equation for me? So if you're taking the logical route and ignoring me and just going to type, plug and chug through your calculator, try and figure it out, good for you, but you're not going to get full credit on this problem. And a problem like this, I would count as almost 6 or 7 points. So once I get this first step, then I can go in here and combine like terms. To kind of make it look nicer, this would be x plus 1 plus x plus 2 equal to 804. If you take this and combine like terms, you have x, and x. And so then that would give me 3x plus, put together the 1 and the 2, plus 3 equal to 804. Now again, there would be another point where I would give you credit. Even though this is an online class, whenever you take an exam for me, I always like to see scratch work from the testing center, and so this is how I would dole out some points. And we'll talk about that when we get closer to any exam, especially proctored ones. Now in order to solve for this x right here, I'm going to have to subtract 3. Subtracting 3 from each side gives me 3x equal to 801, and then divide by 3. And so I got x to be 267. And so again, grab your handy dandy calculator, do 801 divided by 3, and this is how I got my 267. Alright, so I'm not done with it. This thing asked me to find the sum of 3 consecutive natural numbers is 804, and then it would say like find the numbers. So what are my numbers? Come back up here, and the first one is x, so that would be 267. Add 1 to it, my next one would be 268. My last one would be 269. And so credit would be given, again, for creating this model, combining like terms, and then solving out for your 3 numbers. So again, fake cough, fake cough. This is a good test question. You'll also see this in WebAssign, just maybe with different numbers. The next thing that we're going to look at in this section is percent problems. So part 2, percent problems. The first basics that we need to know in working a percent problem is how to set it up. And so I'm going to give you kind of a handy dandy guide here. We're going to talk about part over whole equal to percent over 100. So whenever you're working a percent problem, this is going to be our guide or formula per se that's going to help us to get there. So let's kind of put this into action and work it out. And the next one, it says, what is 30% of 45? And so the first thing I'm going to do is I'm going to draw my two fraction bars. The next thing I'm going to do is I'm going to go ahead and fill in 100. 100 is always in there. What is 30%? Now the reason that 100 is always in there is because 30% written as a fraction is actually 30 over 100. And so that's why we always put 100 there. Basically, we're putting the fraction, the percent written as a fraction on one side. And so 30 goes up here. I don't put my percent sign because it's over 100. And these two, again, these two are equivalent. Then I'm going to say, okay, is it part or is it whole? And back in grade school when you first learned this, you never did anything over 100%. But we're in college now, and so we're going to do things over 100%. So don't just go, oh, I'm going to put it here, or it's a small number, I'm going to put it here. Think about what the problem is asking. What is 30% of 45? So that means that we're looking for what the 30% part is, looking at a big number of 45. And so since I filled in every blank I know and I only have one left, I'm going to put an X there to represent what I'm looking for. And in this case, what I'm going to be looking for is the per part of 45. Now that I have it set up, I'm going to solve it out. And so I'm going to say, I'm going to cross multiply it, or sometimes they talk about butterfly it. I'm going to say X times 100. X times 100 would be 100X equal to, and then I'm going to cross multiply the other way, 45 times 30. And so you grab your handy dandy calculator, and 45 times 30 would be 1350. Then you take this and you say, okay, let me divide both sides by 100 in order to get X by itself. So I divide both sides by 100 and I get X to be 13.5. So then look at the problem and see if 13.5 makes sense for the problem. 13.5 is 30% of 45. Does that make sense? What is 30% of 45? Would 13.5 sound like a reasonable answer? And although a lot of people don't like to work problems where they have to set it up themselves, I do like problems that I can go back to and see if it logically makes sense for the answer, so it's kind of a quick check. And 13.5 does make sense for this problem. So in this problem, we're going to do the same technique as the previous one. This one says 459 is what percent of 340? So the first thing I'm going to do is I'm going to go ahead and set up my two bars. Now remember, we talked about how your percent went over 100, so I'm going to go ahead and put 100 on bottom here. I noticed that it says what percent, and so that's what I'm going to be looking for. So I'm going to go ahead and put X over here on the right, halfway there. 459 is what percent of 340? So in this case, you're actually going to put 340 on bottom and 459 on top. This is what I've talked about on the previous slide. Don't just assume your smaller number goes on top. If you're talking about percent growth in your business, if you're talking about percent growth in your real world applications, sometimes it's a good thing to have over 100%. So again, we're going to follow the same steps as the previous one. We're now going to cross multiply both ways. 459 times 100 gives me 45,900 equal to 340x. In order to solve for x, I would need to divide. You'll notice that these are similar steps to what we did in the previous one. You cross multiply, you write your linear equation, and then you divide in order to find x. So you take both sides, divide it by 340. You grab your handy dandy calculator, because it's not about arithmetic in this problem, it's about finding the percent, so don't miss it due to a little arithmetic issue. And this gives you 135. So again, you go back up to the top and you say, does 135% make sense for this problem? 459 is 135%, notice I'm plugging it in here, of 340. That makes sense because 459 is a larger number, so I do want over 100%, but not too large because it's not doubling up on the 340. And so make sure, again, you set up the problem, solve it correctly, make sure you do your arithmetic correctly, and then see if it makes sense for the problem.